Hello everybody, today you can see a power supply. It's made on key A7500 IC. It's the same IC as TL494. It's an old power supply, but it has a PFC, passive PFC, 500 watts. It's pretty powerful for its time. The reason why I decided to make a video, because we can make a LED power supply from this old ATX device, and I am gonna show you how we can make it. First, let's check it together. I already checked it. It's a working power supply, but just want to show you. As you can see, my tester shows all the voltages. That's exactly what we need. The fan is spinning, so we can proceed, open it, and try to make a power supply. Regulate it. I'm gonna unscrew and see. So remove the screws. That's the inside. Power supply is cleaned, which is good. Here is a choke of PFC. I'm gonna remove it after, because it's gonna take a lot of space, which I need in the future. Okay, the PCB is out. I removed the choke, tested the power supply one more time just in case everything works. So then we should disable the supervisor IC, which supervises the output voltages. You can see it on the screen. And after that we will be able to modify the power supply. Also, I'm gonna remove the excess wires and keep only those. Okay, everything which we don't need is removed. Only the output Schottky diode is present so far, and those wires, plus and minus. Also, we should remove excess coils from this ring and leave only one, and then we will place it something like this, which you will see in a few moments. Okay, I put the inductor, removed the excess coils, we don't need them. You can see it coming from the output of rectifier diode to the plus wire. Here I put two resistors. I will show you on the schematic the values of those resistors. Here temporarily I put some connectors for checking, and now we should disable the protection of the supervisor, as I said before. And for this we should remove only one diode, small diode, that goes to TL494. And that's the schematic you're gonna see. That's the diode, and by removing it we removed all the protections, and now the power supply is gonna show the maximum voltage that it is capable to deliver on this schematic with those elements that came from the factory. We can slightly increase or decrease the value that we see now, but also I will talk about it later in the video. Resistors slightly warm, which is good. Those resistors are needed that the power supply is always loaded, and without them there might be problems. Okay, now we should modify the schematic. That's the basic one. There are lots of videos about this topic, about how you can modify it, so you can stop the video, check it, and make your own. I'm not gonna describe everything in the video. Okay, I modified some new elements added. Here is a potentiometer for voltage regulation. On the schematic you saw it in the below section. I added it exactly like in the schematic, and now I'm starting from 0 to up, increase, and as you can see the voltage is also increasing. So far we are reached the point where we can regulate the voltage. We should always check after one step that we are going in the right direction. Now we should see the maximum voltage that we saw before. As I said, I'm gonna slightly increase the voltage. We had previously 22, something like this. I'm gonna make it 24. I decided not to show you how I increase the voltage because each power supply can have some modifications, and you just need to play around with the voltage divider on the first leg of TL IC. Okay, now I'm gonna show you how the current regulation is done. Here you can see two power resistors, 0.1 ohm, so in parallel there would be 0.05 ohms. I'm gonna put it in between this place. I made a cut from the winding of the transformer and to the minus output of the power supply. Here is also would be a wire just to connect those two traces, and here I will put resistors. Now you can see the cut I made for installing current sense resistors, which I already did, as you can see. Now I'm gonna put back a radiator and proceed. Here you can see I connected a small potentiometer because I don't have a large 10K potentiometer, which I'm gonna order and then install properly. For now it's enough for testing. I connected a light bulb, put some voltage, let it be 9 volts, like this. It's enough for testing. And now I'm gonna connect the load. As you can see, the voltage goes low because the potentiometer is in the limited value. So if we increase that value just like this, we can see that the current through the load is increasing. So our current regulation and current protection works. I can put it in the middle position, and when disconnecting we see our 9 volts. When connecting back we see something in the middle, so it's the medium current with this load. We can increase it further, and when it reaches 9 volts it's the highest current with this load, as you can see, just like this. Maybe some resistance of the wires is making some error, but anyway, we can increase further, but it make no sense, and everything is working as we planned. So far so good, so I'm gonna proceed further and show you the result. As I said, I'm gonna order some parts and see you later. A month has passed. As you can see, the surroundings is different, and those are new parts. Here is a switch. I modified a little bit. I put a wire and an LED inside. Those are new potentiometers, 10K each. I put a shrinking tube for safety. This cap was too big, and temporarily I put two 35 volts capacitors. This will allow me to decrease ESR and get some space that obviously we are gonna need. And now, as you can see, I made some holes already, just putting approximately everything and judging by my view. Maybe you have some different views, maybe you have some different ideas. Some people made those holes on the right side, some people just made it different, so it's up to you. You are the creator. I decided to put it like this. As I said, I removed this one because that takes a lot of space. I don't need PFC, it's not that kind of application. I'm not gonna use it very frequently, very often, so it's not needed, but I tried actually. I thought maybe I would put it back, but there is no way. Anyway, now I'm gonna connect the emitter. I'm not gonna show you how this is done, lots of videos, so if you are familiar with electronics you can do it, no problems. Here you can see how it looks like in my case. Also you can see I put glue for improving thermal conductivity and eliminating some noises which can be in the output choke. Also I connected the fan from the 5 volts standby. As you can see, it's enough for the load and it's not gonna overheat. The standby voltage is 5 volts and 2 amps, so the fan takes about 100 milliamps. Now you can see the final appearance. Here you can see the wires I connected. I decided not to make any output terminals on the side of the casing. Also, at first I wanted to put those wires from a car. It's really flexible, 150 amps, but then I thought it's way too much for this power supply. Maybe later I'll put it, but not for now. I've got these really flexible power cords from I don't know, probably iron. Yeah, it's iron for the closes, and it's flexible and it's really pretty thick inside, so it's enough for the current, which is, by the way, is gonna be 10 amps. Now I'm gonna show you. As you can see, 5 amps, and if I increase the current, almost 10, but the emitter is not precise, and actually on this almost 13 amps its actual value is 9.8 amps, so let's say 10 amps. Here we have 60 watts light bulb from the car, and at 11.1 volts it takes about 5 amps. So you can see it's not precise, but close enough. The regulation starts at this point, at this position of the potentiometer. The regulation is working. By the way, as you can see, I use crocodile connections at the output, and also I decided to make some of this from 2 used pans and a piece of wire and some shrinking tubes. Those really nice probes. I really like those because I spent only 20 minutes and actually didn't spend a cent for this. I've got all the accessories for doing this. For me, this is the best decision to make it like this, to have crocodiles and some probes. Some people prefer only probes, but I don't think this is the best decision. Okay, it's working. Now we should finish those probes. As you can see, it's not sharp enough. In order to do this, we need the power supply. We already have it. That's the wires. We also have those with crocodiles. And also we have to get a hard drive, as you can see. I also modified it, get a driver for about $5 and some sandpaper disc I cut myself, and this is a quite useful and compact tool. We just need to help it a little bit like this, and it's working just okay for tiny purposes like this one. Now it's gonna be a little bit loud, please forgive me, but I just wanted to show you where and when we can use crocodiles. You cannot do this with probes. So if you put probes, you won't be able to do it like this. And just like this, we are done. Now I'm gonna show you how I'm gonna use those. I hope you will find it useful also. Nice and sharp. Okay, at first I didn't show you the maximum voltage. Now I'm gonna show. As I said, I only need 24. There is some flickering, you cannot see it with your eye, only on camera. 24 precisely. Let's take current limit, and there was some noise, and as you can see, current limit is working. 24 volts. I've never used much voltage in my work, so 30 volts are not needed for me. Okay, let's, for example, consider the situation when we need to charge a lithium-ion battery. You have probes, and you cannot charge this battery with probes. Yes, but with crocodiles you can use it really inconvenient way. Just need to put 4.2 volts, put some current limit. This battery 2000 milliamps capacity, 1 amp should be enough, the right choice. So current limit is set, and now we connect plus and minus. We can turn it off just for safety. Connect properly and turn on. 1 amp is charging, voltage decreased. When the battery would be charged, the voltage would be 4.2 volts. Nice? I think it is nice, at least for me. Next, some examples. Here we have an Arduino with some pins, and we need to connect it. We cannot use crocodiles because those are too big, but for these purposes I put small wires with a mother and father connection. And as you can see, I used mother connections and Arduino is working. Also, we can use the testing board, the probe board, put some current limit just in case, and test everything we need. Also, those tiny wires are useful for me. I always need to check fans. It is not really good to use those with probes because you have to you need a third hand for this purpose. 1 hand for holding the connector and 2 hands for holding the probes. That's why really useful those 2 wires, just like this. If we don't need those, we are connecting father connector in mother, and they are not bothering us, they are not gonna short anything, so it's nice. Let's see something else. And for another example, here is the motherboard. Let's set 19 volts, put some current limit, just like this, connect the crocodiles, turn it on, let it be 2 amps, which is enough. And we cannot use these connectors, but we can connect it like this on the ground. Also, you can do it on the video cards and other big boards and connect the probe like this and just put voltages here and there, touching. For me it is convenient. Decrease some current. I intentionally put the probe on the ground so you can see that it's working. Also, it's not gonna put from the crocodile, it's really hard to set it free. Let's have another example. Here I found some board with LEDs and we need to check it. We decrease the voltage, let's say to 3 volts. That's the voltage for testing LEDs. Also, we have to decrease the current, probably. By the way, the lowest current with this power supply is about 10 milliamps. Below that current is voltage is unstable, it goes low. Here I put 200 milliamps. That's enough, because when we connect the voltage, as you can see, it's not even in the full brightness, so there is no need to decrease the current. And as you can see, we are now using 2 probes, which is also convenient exactly for this purpose. Let's test one more time the maximum current. As I said, the emitter is not precise, certain amps it will show. In fact, it will be 9.8, and it's enough for all my purposes. It's working, as you can see. The power supply is saved from trash. We give it another life, so it will take a nice place in my lab, and it's gonna serve me for a long time. You can modify how you want it. You can put some output terminals. Also, I'm gonna seal these holes. Terminals you can put here, or you can do it whatever you want. So that's it for this power supply. I hope you like it. I hope you find something useful for you, and see you next time. Goodbye. Thank you for watching.